Now we're going to look at two examples where we're using our quotient properties in addition to the product properties. So I would recommend, if you're dealing with problems that have fractions in them, you can simplify the fractions first and then deal with the rest of the problem, the multiplication. So let's split this fraction on the top left into two components. We've got the coefficients 6 over 3. That's just a regular fraction or a regular division problem. So 6 divided by 3 gives us 2. Then, for our variables with exponents on them, the quotient property says that we can subtract those exponents, so that gives us x squared. And we haven't done anything yet with this times 4x to the third, so we'll just bring that down. Now this is a multiplication problem. So we're going to multiply together the coefficients. 2 times 4 gives us 8. And if we add together the exponents on the common base x from x to the power of 3 and x squared, that gives us x to the power of 5. So we took care of the fraction first, and then after that we multiplied using our product property. Let's tackle this problem on the top right now. So before we try to multiply these together, let's simplify each fraction separately. In the denominator of this fraction, we have an exponent outside of parentheses, so we should distribute that to both of the terms inside the parentheses. I'm going to just keep the top of this fraction the same for now and deal with the bottom. 2 to the power of 4 is 2 times itself 4 times, which is 16. And x to the power of 4 is x to the power of 4. And let's just bring down this other fraction. And now, before we multiply these, let's simplify each fraction separately. First, looking at the coefficients in this fraction, the 3 over 16. If there was some common factor we could divide both of those by, we could reduce this. But there is no common factor of 3 and 16 other than 1, so we'll just leave that as 3 over 16. We have a common base, x on top, divided by x to the 4th on the bottom. Remember that this x is like x to the power of 1. If we subtract the exponents, 4 minus 1 is 3, and x to the power of 3 is on the denominator because the bigger exponent was on the denominator originally. Now looking at this fraction, we have x to the third divided by x squared is just x, and that x is in the numerator, because the exponent on the numerator was bigger than the denominator. So now we have to multiply this fraction 3 over 16x to the third times x. Well, remember that any term by itself can be considered as a fraction, just with a 1 in the denominator. So once we do that, then to multiply these expressions together, we're going to multiply the numerators together. 3 times x is equal to 3x. And if we multiply the denominators together, 16x to the third times 1 is still 16x to the third. Now there's one more thing I can do to simplify this. X in the numerator divided by x to the third in the denominator will leave us with just x squared. And that x squared will be in the denominator because the bigger exponent was in the denominator.